I apologize in advance for my terrible handwriting, but I want to be able to sum up what happened in class and something you can use for your homework also. So what we did today, one of the things that we talked about today in class was that if we have, for example, x times y equaled 0, we said with a product of 0, what has to happen is that either this part has to be 0 or this part has to be 0. That's the only way we can have a product of 0. 0 is so powerful. Totally amazing. Another one we looked at is if we had like x plus 5 times 2 was equal to 0. We knew that this part couldn't be 0, but this part could. And the way that that would be 0 is if x were negative 5. Negative 5 plus 5 gives us 0, so the whole equation becomes 0. Another example we talked about was like x minus 4 times x minus 3 equals 0. That we end up getting then, we're not going to factor it, we just look at it in terms of its pieces. For this to become 0, x could be 4. Or for this to be 0, x could be 3. In either case, the entire equation will become 0. So then we looked at, well, what if we have something like x squared plus 7x, oh, sorry, that's not a good example. What if, no, that's fine. X squared, plus 7x plus 6 equals 0. What I would do here to help myself out is I would factor it first, x plus 6, x plus 1. And now I can use this awesome power of 0 again, like I used here and here and here. I can use it over here instead. So again, for this to be 0, x could be negative 6. Or for this part to be 0, x could be negative 1. Okay, let me look at one more with you. So then we said, as a final sort of piece, was that if we had x squared plus 8x plus 10 equals 1, that what we really want is we really want this set equal to 0, this trinomial. So that gives us x squared plus 8x plus 9. Sorry, that's meant to be an x equals 0. And then, sorry, that's not going to work. That's not going to factor. I apologize. So let me make this instead an 8. Sorry. I'll call this an 8, and then when I subtract, I get a 7. So I get x plus 7, x plus 1. I close it, and either x was, in this case, would be negative 7, or it would be negative 1 for here. The next big piece that we talked about was looking at y equals x squared as a graph. So what we did first was we made a table with our x and y values. We went from negative 2 up to 2, and we found that we were at, when I square negative 2, I get 4. When I square negative 1, I get 1. Square 0, I get 0. Square 1, I get 1. Square 2, I get 4. What we found here was when we plotted points was that we had this, when we plotted these by hand, is that we saw that it actually went like a really cool V, like a U sort of shape. We said it wasn't really a V because it wasn't like the sharp ending at the bottom, at the base there, which we'll call the vertex. On the origin, it wasn't sharp. It was rounded going up. So we're saying that this shape, this general U shape, is something that we're going to see again. And this is, we gave this today, this is called a parabola. And so this defines, like this equation here, which we've been factoring all these different expressions for, when we set it equal to an equation, set it equal to y, we end up getting this behavior on the coordinate plane. What I want to do is look at this one here with you in terms of a couple different things. Let's first go to a t-chart here, x and y. I'm going to start out a little bit further over, negative 5, negative 4, negative 3, negative 2, negative 1. And we'll plug in different values. I get 25 and negative 25, those cancel out. I get 6. I get I get 16, negative 20. So I'm at negative 4 plus 6 is 2. I get 9 plus 15. No, sorry, plus negative 15. So that's negative 6 plus 6 is 0. I get 4 and negative 10. So that's negative 6 plus 6 is 0. It's easy, I'm sorry. And then I plug in the negative 1. So that's 1 plus negative 5 No, that's fine. Sorry, 1 plus negative 5 is negative 4 plus 6 is 2. So I can see, just like it was on the last one, that I have some really nice symmetry, right? I have the 0 and the 0, then I have the 2 and the 2, and we could even, if we wanted to, plug the negative 2 in here, and thinking that we'd get the 6 to get that same similar, that reflection, really. So I'm just going to check it out. That's 4 plus negative 10. That's, sorry, that's 4 plus negative 10. No, I'm so sorry. All right, I can't. This is 0. So 0 should be 6. 0 plus 6, so that's 6. Great. So now let's graph this on the coordinate plane. So I have negative 5 is 6. I have negative 4 is 2. I have negative 3 is 0. I have negative 2 is 0. I have negative 1 is negative 2. And 0 is 6. I'm just going to draw this one as best as I can. Sorry. I'm going to redraw this because it's not good enough. Okay. So if I say here, negative 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. This is going to be a much better graph, I'm sorry. Here, 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 here. Okay, I'm glad you're seeing this instead. And I'll sketch this to look like that. I can see it's generally the same shape as the other one, like that U. And now what we can do is look at and see what's happening here. Where do you see that on your graph? You are going to see that here. Then what I'm going to see is I'm going to take this same graph here, the same equation rather, and instead of graphing it with a t-chart, or in addition to doing that, I'm going to also now say, what would this look like in terms of its factored form? So let me do that here in factored form. So I'd get y equals, and I can factor this into x plus 2 and x plus 3. And now what I'm going to do is I'm going to go back to what we started class with in terms of factoring and setting equal to 0. If I set this equal to 0, I get x plus 2, x plus 3, and my x values are going to be negative 2 or negative 3 when y is equal to 0. So here I can see that here I'm at negative 3, here I'm at negative 2. So when I factor like this, and I set it equal to 0, I'm finding my x-intercept because I'm saying when y is equal to 0, which then is my x-intercept. So my two x-intercepts are going to be these two values.